Alright, we got 15 minutes of fun. Today we are going to be talking about some shortcuts to similarity. Hallelujah. Alright, so, first of all, we learned previously that to check similarity, now remember similarity is that they have the same look, but different size, right? Dilations, okay? So to check for similarity, you have to make sure all the angles have to be the same. Alright, and all sides are proportionate. Those are the two checks. But what if I'm lazy? Honey, what if I'm lazy?
Then you won't pick up your clothes when you get home.
I did pick up my clothes when I got home. Oh, smart Alec. If I'm lazy, I want a shortcut. And I might not always want to check those things. So maybe my shortcut would be I record a video and watch my wife pick up my clothes.
Or throw the clothes under the bed or in the closet.
Or under the rug. Or have Graham do it. Anyways, so we're going to learn about some shortcuts. And we already talked about one shortcut. And that is the AA theorem. Remember that? A couple days ago. Man, your cleaning is really distracting me, honey. I don't even think I spelled theorem right. Okay, alright. The AA theorem. Why can't you go downstairs and like do the laundry or something?
I already did
Kidding.
that.
Kidding. Don't say that, guys, to your wives. Alright, so AA theorem is one shortcut, and that this is okay. I gotta pause this, guys. I'm sorry. Alright, all seriousness now. Okay, so the AA theorem is a cheap way. We don't have to check both of these. The AA theorem only works for triangles. Alright, so it only works for triangles. Okay, so if you are looking at something with 4 sides, 5 sides, 6 sides, 7 sides, 8 sides, 9 sides, you're out of luck. So the AA theorem basically says, hey, if 2 angles match up, alright, I need that light on, otherwise they can't see my beauty. It's got to be, no, the other one. Yep, kitchen one. There we go. Okay. The AA theorem only works for triangles, and so do these other two that I'm going to talk about today. Alright, so the two are S, 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 which is side, side, side. And then we have side, angle, side, or as I like to call, a little sass. Okay. Kind of like Kyla. She can give a little sass every once in a while. Okay. So this is the Kyla rule. The S, like a snake. I'll leave that one up to you. Alright. Okay, so here we go. If the corresponding sides of 2 triangles are proportionate. Alright, now remember, we're only talking triangles here. Okay, so the triangles have to match up. This doesn't work for any other thing. It's only triangles. If the corresponding sides of 2 triangles are proportionate, then the triangles are similar. So basically, if this side and this side were given a fraction, and this side and this side were given a fraction, and this side, oh my goodness, and this side were, oh, you're given a fraction. Alright, I'm gonna undo that. I'm not gonna get through the lesson today. And that side we're given a fraction. Here we go. They would all equal the same number. Hence, okay, you guys ready? We're gonna tackle it. Alright, so determine if these are similar. So now I know if they're all 3 sides are proportionate, they're similar. I don't need to do those other 2 tests. I don't know anything about the angles, right? But I do know by just knowing if the sides are proportionate. So you ready? I am going to go SU. Alright, well, SU is 6. And that's going to match up with PR, which is 12. Alright, so right away I'm looking at 6 over 12, which is half, right? Okay, now, does that match up with UT, which UT, that's 5, over QR, which is that one, right? So 10. All right, what's 5 over 10? That's 1/2 too. So 6 over 12 is a half. 5 over 10 is a half. All right, now we're going to check this other side, and we're going to do blue. And they say go TS. So this length right here is 4. And does that match up with this side over here, which is 8? 4 over 8 is 1/2 as well. These guys are similar, I know, because of the S, S, S. All right. Okay, we're going to try one more. We got to move. All right, so let's see if these two triangles. So is either of these similar to A, B, C? So this is the one I'm testing. I'm testing this one. All right, so I want to know, are any of the other triangles here, say 1 or 2, are those similar to this guy right here? All right, so let's test it out. So first of all, I'm going to take 14, which is my longest side, and I'm going to say, all right, it's 14 over 12. Now remember, I could do 12 over 14. Could do 12 over 14, that's fine. Is that the same thing as, all right, let's grab the another side. Now this is my second longest, that's 10. Now I know, all right, so I'm going to grab my second longest. Just forget it, I'll address it on the next one. So I'm going to go 10 over 9. Is 14 over 12 the same thing as 10 over 9? I don't think so already. I think that one's a bad one. Hence I wrote it in red. Duh, guys, I wrote it in red. Alright, and then the next one is 6 over its corresponding, which is 6. Holy moly, who did this thing? This thing isn't even close. These two aren't even close to each other. 6 over 6 is 1. 10 over 9 is like 1.1 something, right? 1.1 something, I don't know. And then 14 over 12 is like 1.2 or something like that. These are not alike. So this guy is not similar. I'm going to put a big old, let's make it red. This guy, he sucks. He's not similar. Don't marry him. Hey, star guy, don't marry this one. He's not very similar to you. Alright, now let's check out this guy. Number 2. So we're going to test this guy out. And I'm going to say, I'm going to wipe these colors out here. Let's see if this guy's similar. So I'm going to take my longest side, which is 8. Alright, so I'm going to take 8. And that corresponds with the longest side over here, which is 12. Alright. Yes. Yes. Alright, 8 over 12. Is that the same thing as, alright, now I'm going to take, let's take the shortest side, which is 4. Wouldn't you agree? 4 is smaller than 6. Now here's the tricky part. Most people would go and grab this one over here, right? See this guy right here? But that guy's actually longer. Remember, I grabbed the shorter one, 4. And 4 has to correspond with the shorter one, which is 6 over here. Okay, and then finally my middle has to match with my middle length over here, so 6 over 9. Alright. Okay. Alright, 8 over 12. If I type that in my calculator, I should get 0.66. Repeating. 4 over 6 is 0.66. Repeating. 4 over 6 is 0.66 repeating. And 6 over 9 is 0.66 repeating. So this guy is similar. I'll put an E on there just to tick people off. That's not how it's spelled, just you know. I just like to grind your English skills. 5 more minutes, guys. We're cruising along. Alright. Here's this other rules. Alright, so we just learned side, side, side. If we know those 3 sides are proportionate, they're similar. Now, here's the other one. Side, angle, side. A side, an angle, and a side. Now, this one says if an angle is congruent, alright, so if one angle is congruent, and the 2 sides that are attached to that angle, I'm not finding it in here, but in the two sides that are the lengths of the sides that include this angle, so that means basically the sides that are attached to that angle, if those are proportionate, then we're good, all right? So, first of all, you have to have an angle that's similar, and then the two sides that are attached to that angle have to be proportionate. All right, we're gonna be done in just plenty of time. All right, so first thing I notice here is, hey, all right, 61 and 61, those are matching angles. All right, now if I only had one more angle, I could do angle, angle, and I could prove that similarity, right? But I only know one angle, so I can't prove angle, angle theorem. Next says, determine whether the triangles are similar. If they are similar, write a similarity statement. All right, so C and F both measure. All right, okay, compare the ratios of the sides. So here's what I'm going to do. So let's see. Let's take 3/5, right? So let's go 3/5, because that's attached to that angle, right? Is 3/5 the same thing as 6/10? Is that the same thing? 3/5 and 6/10. I believe so. All right, 3/5 is the same thing as 6/10. All right, and you notice these are the sides that are attached to that angle that was similar, right? Or sorry, it was congruent. So this is the angle that matches, so the sides that are attached to that angle, or that make up that angle. All right, let's try another one. Okay, show that these are similar. All right, it says, hint, draw the triangles separately. So I guess we will, pardon my French here, I got 4 and 5. All right, and then I have the big guy here, the big kahuna. And all right, oh my goodness, this is horrible. Let me do this upright. I'm gonna draw with my tool. Oh, that's not gonna be right. Come on. Give me something good. All right, let's try this guy. Yeah, that guy will work. All right, so there's the first guy. Here's the second guy. There we go. Okay, now we know this guy is 4 and 5, right? 4 and 5. And this guy, it's not 8. It's 8 and 4, right? It's 8 plus 4. So 8 plus 4 is 12. So I know this length is 12. And 5 plus 10 is 15 over here, right? Okay, do I know anything else? You might say, I thought we were talking about side, angle, side. I do actually know. Because you see this thing right up here? They both share that same angle. So I know this angle is the same as this angle. Therefore, I have side, angle, side. See that? Now let's see if it works. Let's see if they're equal to each other. So, I know the angles are congruent. Okay, I know those guys are congruent. So now I got to match the sides. Are the sides proportion? So let's take the short side, which is 4, with the short side over here, which is 12. So I'm going to go 4/12. I got 1 minute. And then I'm going to take the longer side, which is 5. Is this equal to 15? Oh my goodness. I'm not going to erase it. I don't have enough time. All right. 4/12 is 0.3. 3. Repeating. 5/15 is 0.33. Repeating. Are they the same? Yes. Similar. Similar. Okay, I think that's it. Okay, so that's it for the lesson. Remember, if all three sides are proportionate, they're similar. if you have side angle side, or if you have angle angle. Bye.